Hello, this is Mr. Agbamu Idonogrene. I'm here to teach mathematics on the topic coordinate geometry. And in today's class, my objectives are define graph and Cartesian plane, define point and coordinate, calculate the distance between 2 points. Okay, let's go straight to today's class. But before I go straight to the class, I want us to look at the topic again. The topic is coordinate geometry. In this topic, all we are trying to do in this topic is how do we do some calculations on a graph paper without we actually plotting the graph. Because what we know in graph is we plot points and join them with line, then interpret the graph. But in this topic, that's why we call it coordinate geometry. In this topic, we are trying to see a way of doing some calculations on the graph without actually plotting the graph. So in this topic now, you are going to get some formulas that you will use to do your calculations. And you may not necessarily plot the graph for you to do the calculations. So take note of that. For example, look at our third objective. We said calculate the distance between 2 points. So when I say you should calculate the distance between 2 points, I don't want you to plot the graph. I just want you to give me the formula. Then with the 2 points being known, you can use the formula to get the distance. So take note of that. This topic is very, very important in mathematics. And with the knowledge of graph, this topic will not give you a problem. So that's why I want to start with the meaning of graph and Cartesian plane. Though I'm not going to treat graph and Cartesian plane in detail, I'll just introduce you to it, refresh your memory on it so that you will know that it is the knowledge of graph that we are using in this topic. So that when you have any problem in this topic, anything you don't understand, then it's better you use your graph to try it, to analyze the question, then you can easily interpret it by using the formula to get the answer. So let's see the meaning of graph. So a graph is just a pictorial method of showing the relationship that exists between two quantities. So you know what that means. You have two quantities, you want to get their relationship, so you need a kind of a picture to bring out the relationship. So a graph is a good way to do that. That's why I would say it's a pictorial method of showing relationship. For example, if I take a velocity time graph in your physics class, you know what is velocity, you know what is time. So when I say velocity time graph, I'm talking about the relationship that exists between the two quantities, one velocity and the other is time. Then from the graph, you can easily interpret what will happen to velocity when time changes, or what will happen to time when velocity changes. So that's what we are doing. And graph is usually done on a squared paper called grid. So you know your graph paper. When we say your graph paper, where is your graph paper? We are talking about that squared paper that have these crossing parallel lines. So that is just that. And for example, let me just show you example to this what I mean. So this is squared paper with crossing parallel lines. You can see the squared. Even this bigger square we have here, you can see another smaller ones inside. So all these crossing lines, they are very important when you want to plot your graph. Just like your ruler, when you have your scale on your ruler, 1 centimeter, 2 centimeter, when you see it, you can easily count in between the centimeter mark of the ruler. So that's what graph also help us to do. You can easily count in between so that you can easily get 1 centimeter, 2 centimeter, just like that, and your work is mainly perfect. At least it's almost perfect when you use graph than a plain paper. Okay, just take note of this. So what is a Cartesian plane? So everything we shall be doing in this topic, coordinate geometry, we are doing it on a Cartesian plane. But as I said, most times you don't need to plot the graph. You just need the formula to solve. So a Cartesian plane is a graph paper. So not just ordinary graph paper now. A graph paper which contains the x-axis, the y-axis, and the scale on the axis. So when you have a complete graph paper, for example like this, so this is a complete graph paper, but you cannot call it a Cartesian plane because it does not have a reference point. And you know when we talk of Cartesian plane, there must be a reference point. It is from your reference point you can locate your point. And you know, when you start locating point and start joining point, that is what we call plotting of graph. So when you locate point, then you start using your ruler to join the point, then you are plotting the graph. That is all about plotting of graph. But in this topic, we are not going to plot, but we are going to get point, then calculate some distances and some other parameters. Time goes on, we shall do more calculations. So if I introduce my axis here, you can see axis. If I introduce my axis here, so now I've put my axis, you can see the y-axis, you can see it, you can see the x-axis here. Yes, then you can see the scale. The scale has been done on the graph. So this is 1 centimeter to 1 unit. So you can see the graph, the scale is increasing by multiples of 1. So this is a 1 unit scale graph. You can see it 1 unit for both x and y axis. You can change the scale if you want. No, so it depends on you. So you can decide to change my scale. For example, if let me just increase it, you see. So I've reduced this. For example, I've changed this scale to 0.5 units. You can see it 0.5. You can decide to bring it to, this is 10 units now. On the y-axis, 10, 20, 30. You can see this minus 10, minus 20, just like that, minus 30, minus 40. So this is 10 unit scale. Then you can also do it on the x-axis also. So that is that. Let me put the x-axis on 5 unit scale. Okay, so this is 5 units. So you can see I'm increasing the size of the box. I want it to be a 2 centimeter box. So this is 2 centimeter now to 5 unit on the x-axis, then 2 centimeter to 10 unit on the y-axis. So but this is not our major target in today's class. So let's go straight to the coordinate geometry, why we are really here. So let me put the setting back to 1 unit. Okay, let me put it. Okay, so this is 1 centimeter to 1 unit. Okay, let me put this also, the x-axis. So we have it now, so 1 centimeter to 1 unit. Alright, let's go to our write-up. So that is Cartesian plane. To take note of that is very, very important. It's very, very important. So now let's start with the first major parameter we have in the graph, which is a point. We say a point is the basic relationship displayed on a graph. You can see, so point is the major parameter we treat in graph, because before you plot any graph, you need to have a point. It is point you are locating, then you join the point and you start interpreting your graph. You try to see how the point varies. Those are the things we do in graph. That's why I call it the basic relationship displayed on a graph. So it's the basic relationship. Every other thing comes after you have your point. But this is what we need in this topic, and this is where you need to pay more attention. We say each point is identified by a pair of numbers containing 2 coordinates. So this is very, very important. So if you want to identify every point on a graph paper or on a Cartesian plane, you need 2 coordinates. And these 2 coordinates are numbers. You can see what I have here, by a pair of numbers containing 2 coordinates in the form of x, see, comma, y. So when you see something like this in mathematics, you have a bracket, you have the first number, comma, you have the second number. It is called a point. So the x and y, they are just coordinates. So this first number here, which is x, is the x coordinate. Then the second number here, which is y, is the y coordinate. So you can see this example I have here. I say e.g. that's example point A. If I say A is a point, or if I say point A is, you can see it, A, then I open bracket 4, 2. That means point A has coordinate 4 and 2. These are the coordinates of point A. So with these 2 coordinates, I can easily locate my point A on the Cartesian plane. I can see what this value means. 4 is x coordinate. You can see the first number is always x. So this is the general form of representing points in coordinate form. So this is it. So the first number, which is 4, is x coordinate. Then the second number, which is 2, is y coordinate. Before I will demonstrate this on a graph, let me explain what coordinate means before we go to the major target for today's class, which is distance between 2 points, and that is the end of today's class. We say coordinate is one of a set of numbers. You see, we say a coordinate is one of a set of numbers used to identify a point on a graph. See, it's just one of a set of numbers we use to identify a point on a graph. That's why I said each point is identified by a pair of numbers containing 2 coordinates. So you must have 2 coordinates for you to identify a point. So a coordinate is just a set of one of those numbers. For example, this 4, 2. So 4 is a set of, it's just a coordinate of the set of the 2 numbers we have to form the point, the coordinate. And 2 is also one of the set of numbers. So that's what I mean by coordinates, a set of numbers used to identify a point on a graph. Then take note of this second sentence I have here. I said each point is identified by both x coordinate and y coordinate. See, that's what I've been explaining so far. So every point we have on a graph, each point on a graph is identified by x coordinate and y coordinate. So the first number is always the x coordinate, the second number is always the y coordinate. So take note of that. Even when you are plotting your table, when they say draw a table for the graph you want to draw, it is the coordinate you are putting on the table. The x values, you have them under the column of the x in the graph, then the y values, you have them under the column of y. So each point, you see there are have the 2 coordinates on each point, because those are the things you do on your graph. You see, when x is 4, y is 2, just like that. So take note of that. So now look at this next paragraph I have here. I say the x coordinate of a point is a value on the x-axis. See, very important. So that 4, which is 4 is x coordinate. So the x coordinate of a point, see, of this point A, the x coordinate, which is 4 in this example now, is a value on the x-axis. So this 4 is a value on the x-axis that tells you how far the point is from the reference point. See what I've been telling you about the Cartesian plane. So when you have your Cartesian plane on the graph, so you are set to plot your graph now, then you start with the first coordinate of the first point. So for example, point A, where the first coordinate is 4, then you go to the x-axis, then you look for 4 on the x-axis. So that's why I say it's a value on the x-axis that tells you how far the point is from the reference point. So you start from the reference point, you move and look for 4 on the x-axis. Then the same thing, the y-coordinate of a point is a value on the y-axis that tells you how far the point is from the reference point. So those are the 2 main information you need. So with this, you are done with the introduction to coordinate geometry. So let me just demonstrate what I have here. So if I have point A, for example, let me go to that, my graph paper. So this is my graph paper. So if I say, okay, point A is 4, 2, that's what we have here. So this point A. All I need to do here is, let me get my point. I have my point. Let me see if I can do some setting here. Okay, I need, let me put both name and value. Alright, so let's just put the point somewhere here. For example, I don't know if you can see it clearly. So this is the point A, is equals to, as you can see, let me move it to 0 points. So if I move it to our 0 point, I think you can see it clearly. Okay, alright, so now look at the coordinates here. You can see it, point A. See, point A is 0, 0. So we need to locate point A on the Cartesian plane now. So how do I do that? I said the first number is the x-axis, and that the example we have there says 4, 2. So 4 is the first number, and you locate 4 on the y-axis. So all I need to do is to move this point A. See, I'm moving it along the x-axis till I get to 4. That's where I'm going to stop. You can see 4. This is 4 here. So that is how I will locate point A on the Cartesian plane. So I'm now there now. So you can see 4, 0. I've not started moving on the y-axis. So I've located the first coordinate of the point A, which is 4. So let's locate the second coordinate, and the second coordinate is 2. So on this 0.4, I will now rise up. See, I'm rising up till I get to 2, then I will stop on that place. So this is point A. You can see it. X coordinate is 4, Y coordinate is 2. So by the time you have this idea, you see there's no issues with that. So this is how you locate point on the Cartesian plane. Alright, now how do we get distance between 2 points? So this is where we are stopping in our class for today. So how do you get distance between 2 points? Now, you have 2 points. For example, let me take this one. Let me show you this. Okay, so this is an applet I just designed for this class. See it. So I have show x1 and y1. Let me put the slider. You can see x1 and y1. You can see them. Let me put the first point, which is point A. So what I have here is my x1 is the x coordinate for the first point, point A, and my y1 is the y coordinate on the first point, point A. So you can see x1 is equals to 2. You can see it. So 2 comma the y1 is equals to 1. So I want to get distance between 2 points. That means I need another point. Okay, let me show x2 and y2. You can see x2 and y2. Let me show the point, the second point. You can see it, point B is the second point. So x2 is 5. This is 5 here. You can see it. The y2 is 6. You can see. So you can change the coordinate depending on the question. You can change the coordinate. You can see x2, y2 is now 1. You can see it here. Y2 is 1. Just like that. You can change it. The same thing with your x1. You can change it if you wish. You can see it's now in -2, -4. See point A minus 4, 1, just like that. Okay, but I want to derive an equation because you may not be asked to draw a graph in this topic. Now most times this topic is common in objective question, most times in your JAM examination, even in WAEC exam. So this topic is mainly in objective, though we do have it in theory, but they are not too common. They are mainly in objective, especially in JAM exam. So you don't expect to have your graph paper and start plotting points, start drawing the line, and start measuring the distance. If I join, let me join line AB. So I've joined line AB. If I now say what is the distance from A to B, you cannot start plotting this graph, taking your ruler and start measuring this line. There is no time for that. No JAM. I know our JAM exam of these days is even computer based, so the time to do this is not there. So you just need to know the formula and apply it very fast and get your result. But I just need to show you this so that you can understand the topic very well. So how do I derive an equation for my distance between 2 points? So let me take this point now, A and B. So let me use this example to derive it. So all I need first to derive my distance between 2 points, I need to draw a straight line from here down to my x-axis, but I need a broken line. I need a broken line. I don't want this. Let me do some setting. Okay, this is the line I need. Okay, to this place, which is point D now. Okay, I have another one here to this place, which is point E. I have another one here to this place, which is point F. I have another one here. So this is what you draw on your paper if you want to derive distance between 2 points. Just pay attention to what I'm doing. Then I join these two here. I have my point H. Alright, so now you can see what we have now. You can see that the distance we need is, let me move point A out so now we can see it clearly. So this is point A. Let's put this here. Okay, let me leave this as point E. Okay, sorry, this point is already point A, which is point A. So leave here as point H. Okay, now if you study this diagram very well, you will see that A, B, and H have formed a triangle. You can see it. And which kind of triangle is this? you discover that this triangle is a right angle triangle because the angle between this horizontal line and this vertical line is 90 degrees. If you wish, you can measure the angle. It is 90 degrees because your x-axis and your y-axis, they always meet at 90 degrees. So this is parallel to the x-axis, then this line is parallel to the y-axis. Let me just put it there. I want just value. Okay. I want the distance from this point to this point. Oh, sorry for that. Okay, I want this angle. You can see there 90 degrees. Let me put it in so that we can get it well. Okay, you can see that the angle is 90 degrees, though it's labeled at the other end, but it's also 90 degrees. You can see, so this is 90 degrees. Okay, so now that we know that this angle is 90 degrees and this triangle ABH, you can see that means it's a right angle triangle. So if triangle ABH is a right angle triangle, that means we can take the distance, we can get this distance from E to D. Just look at the label E to D, which is this distance. Then we can get the distance from B to H. You can get it here. BH and EH, which is same thing as ED. But let me use AH because this is our target, AH and BH. So how do I get this distance? Remember, I called x1, this one is x1, this is y1, then this is x2, this is y2. So if this is x1, y1, x2, y2, then the distance from H, you can see H, see this is x2, sorry, this is x2, which is 5, see x2, which is 5, then minus x1, see, which is 2, you can see it. So x2 minus x1 is this distance here. Let me put my pen so that we can get it well. So this distance here is, this is x2, this is x2 minus x1. You can see it. You know, from this point H, when you trace your graph, this is x2, sorry, this is x2 5. I see it, that's x2 is 5 minus, you can see x1, which is 2, see x1, which is 2, so x2 minus x1 will be this distance from A to H, so that is this distance. Then this second distance here, which is BH, you can also see y2, you can see y2 is also 5, see y2 is also 5, which is 5, you can see, which is y2 is 5. So when you say y2 minus y1, you can see y1, which is 1, you can see it here, you can see y1 is 1, will be this distance, you can see it, y1. So that is this distance, and the distance we need now is AB. This is the distance we need, AB, that is the line. So if you get this approach, you can see that you have no problem. So it's the formula we need. If you can get the formula, you are okay. So what this formula means is the first point x1, second point now, which is x2, x2, x1. So when you subtract 5 minus 2, you will get the distance from here, which is correct when you study this graph. I want to know the distance from A to H. You see, from 0 to A is 2, you can see 1, 2. Then from 0 to D, you can see the distance 1, 2, 3, 4, 5. So how do I get the distance from A to H? I'll just do 5 minus 2, which is 3. From A now you count 1, 2, 3. See, the distance is 3. So that's what we are doing in this topic. I want you to get it very well. That's why I decided to bring out this. So with this idea now, what do we do to get AB? Since this triangle ABH is a right angle triangle, all I need to do here is to apply my Pythagoras theorem, and that is the end of the work. So I think you get this diagram very well. So just sketch this down on your paper if you want to understand it. Trace your lines. You can label the point x1, x2, y1, y2, just like that. And it's okay, so that you can get the formula in case you forget it when you want to solve. You can derive it yourself, and that is all. So when you are through with that, let me remove this so that we can finish our work. So when you are through with that, you can now go to your solution paper. So now let's derive the formula. We have already seen it in that place that when we use Pythagoras theorem, so using Pythagoras theorem, what are you going to get when you use Pythagoras theorem now? AB is the distance we want. We need distance AB, which is AB is now going to be equals to, that is AB square. Remember your Pythagoras theorem, square of hypotenuse. AB is now the hypotenuse. If you look at this, let me show you the triangle again. So hypotenuse, anywhere 90 is facing, is the hypotenuse. So AB is the hypotenuse. So Pythagoras theorem says the square of the hypotenuse will be equal to the sum of squares of the other two sides. So if I go down now, AB square, I need to put AB in brackets. So AB square, so have AB square will be equal to the two distance I have now, put them in bracket, x2, have your x2 minus x1 you square it, plus open bracket also, which is y2 minus y1, put it in bracket, square it. So this is Pythagoras theorem. So by the time you get this, the next thing is you remove your square by square rooting both sides. So if you square root both sides, square will disappear from this place. So if you say square root both sides, you are going to get AB. I'm going to get AB will be equals to, you now have your square root, everything you have here, square root of all the values that are here, which is open bracket x2 minus x1, don't forget to square it, very important, then plus open bracket y2 minus y1, and you square it. So that is all. So this is distance between 2-point formula. With this formula you can solve any number of questions and you will get the same result. So let's use this formula to find this distance now. So let's find distance AB using that formula. We said x2 is 5, y2 is 5, then x1 is 2, y1 is 1. Let's apply it to that question and get the distance. So if you have a question like this, okay, let's take this as let's say they say find the distance. Let me position it on this end. Then they say find the distance between the points. Find distance between the point. So those 2 points we have there, you have your A, open brackets and close. The first point is 2, 1, and the second point is, which is point B in that side. The point B is 5, 5. So this is the question. Now find the distance between the 2 points. Let's take this as example. For example, you are asked to find this. So you don't need to plot it on the graph paper just like what I did there. You don't need to plot and start using your ruler to measure or doing all you just need to do is know this equation, know this formula, and you are done. So since the question says we should find the distance between point A and point B, and this is the formula we have derived. So all you need to do is the first point is the x1, y1. The second point is x2, y2. Substitute into this formula and you are done. So if I have my distance AB, all I just need to do is AB will be equals to put your square root, open your bracket. The first point there is 5. You have 5 minus 1. Sorry, let's see. 5 is x1. Okay, 5 minus 2. You square your results plus, open bracket. You have 5 again, which is y2. 5 is y2 minus 1. 5 minus 1. And make sure you square it. So that is it. Then do your solution, solve your works very well, don't make mistake. So this will now be equals to square root. So this is 5 minus 2 now. It's going to give us 3. You have your 3 square plus, this is 5 minus 1. It's going to give us 4, which is 4 square. Then you go to the next step. AB now be equal to, then 3 times 3. So 3 times 3, which is 3 square, will give us 9 plus 4 times 4 will give us 16. Then you move on. AB equal to, so this is 9 plus 16. We are going to have square root of 25. So 9 plus 16 will give us 25. Then final answer for this distance is AB will now be equal to square root of 25 is going to give us 5. You know, no unit is given in this question, so you just write 5 units. Just write it like this. So that will be your answer. 5 units is your answer. But if it's given in centimeter or millimeter, whatever unit you put it in. So this is how we find distance between 2 points. So take note of this. You can see the answer we got there, 5 units. So whatever number of points are given, just take note of the coordinate, the first coordinate and the second coordinate of the first point. You call it x1, y1. Then the first coordinate and second coordinate of the second point, you call it x2, y2. Substitute into the formula and use this formula. You get distance between 2 points. Always put unit as your SI unit of the answer. Take note of that. So before we go for today, let me just show you what we did. If I want to get this distance here, let's see if that 5 we got there is correct. Let's measure distance. Okay, let me use value. Sorry, not this. Okay, let's just get it. So this is the distance. You can see the answer. The answer is 5. So the distance is 5. You can see that the same result we got in this place. You can see 5 is the answer. You can see that you can actually get the same result while plotting your graph, but the time in plotting graph may not be there to solve a simple question like this. So take note of this. So this is how we find distance between 2 points. So you can practice more questions in case you need questions. You can practice this. Just 3 simple assignment questions. Just practice them using the formula, and that is all for today. In our next class, we are going to solve more wire questions. But before we do that, we still need to do other aspects you need, like midpoint between 2 point, gradient, and the rest. So in our next class, we shall look at the midpoint between 2 points. So I hope you enjoyed today's class. So take care and have a nice day.